In today's lecture, we'll be discussing software engineering and providing a framework for understanding the key concepts and practices involved in software development. Software engineering is a process of designing, developing, testing, and maintaining software products. It involves the application of engineering principles to software development, with the goal of creating high-quality software that meets the user's needs and expectations. It is a team effort that requires collaboration and communication among team members, stakeholders, and users. It involves using tools and techniques such as modeling languages, code repositories, and testing frameworks to improve software quality and efficiency. There are various software process models, each with its own set of activities, outputs, and outcomes. Software process models define a set of activities that need to be followed in order to develop software. Different process models exist, and the choice of process model depends on the project requirements. Some common process models include the Waterfall model, the iterative model, and the Agile model. Waterfall model. The Waterfall model is a linear sequential approach to software development. It consists of several distinct phases, each of which must be completed before moving on to the next one. The phases include requirements gathering, design, implementation, testing, and deployment. In this model, each phase has its own set of activities, and the output of one phase becomes the input to the next. Iterative model. The iterative model is an incremental approach to software development. It involves breaking the development process into smaller parts and then developing and testing each part separately. Each iteration involves a cycle of requirements gathering, design, implementation, and testing, and the outputs of each iteration are used to inform subsequent iterations. The goal of the iterative model is to create a working software product at the end of each iteration. Agile model. The Agile model is an iterative and incremental approach to software development that emphasizes flexibility, adaptability, and collaboration. The Agile model is based on the Agile Manifesto, which values individuals and interactions, working software, customer collaboration, and responding to change. The Agile model involves breaking the development process into smaller, manageable pieces, called sprints, and developing and testing each sprint separately. The goal of each sprint is to create a working software product that can be demonstrated to stakeholders. Process activities are the individual steps that need to be followed to complete a software development project. Process activities can be organized in different ways depending on the process model being used. Some common process activities include requirements gathering, design, implementation, testing, and deployment. Requirements gathering. Requirements gathering is the process of identifying and documenting the needs and expectations of stakeholders for a software product. This involves gathering information from stakeholders about what they want the software product to do, how it should look and feel, and what kind of user experience it should provide. Design. Design is the process of creating a plan for how the software product will be built. This involves creating a high-level architecture of the software product, specifying the components that will be used to build it, and defining the interfaces between those components. Implementation. Implementation is the process of writing the code that will make up the software product. This involves translating the design into actual code, and testing that code to ensure that it works as intended. Testing. Testing is the process of verifying that the software product works as intended, and that it meets the needs and expectations of stakeholders. Testing involves creating test cases that simulate different scenarios and use cases, and then running those test cases to ensure that the software product behaves correctly. Deployment. Deployment is the process of making the software product available to users. This involves installing the software product on the user's system, configuring it, and providing user support as needed. Coping with change is an important aspect of software engineering. Change is inevitable in software development, and it can come from various sources, such as changing requirements, changing technology, and changing stakeholders. Coping with change involves identifying and managing change, and ensuring that the software product can evolve over time to meet the changing needs of stakeholders. One framework that is commonly used to manage change in software development is the Rational Unified Process, RUP. The RUP is a process framework that provides a structured approach to software development. It is based on the Unified Modeling Language, UML, which is a standard notation for modeling software systems. The RUP consists of 4 phases: inception, elaboration, construction, and transition. Inception. The inception phase is the initial phase of the RUP. It involves defining the scope of the project, identifying the stakeholders, and creating a preliminary project plan. The output of this phase is a vision document that outlines the goals and objectives of the project. Elaboration. The elaboration phase is the second phase of the RUP. It involves defining the requirements of the software product, creating a detailed design, and developing a prototype. The output of this phase is a software requirements specification, SRS, document that outlines the functional and non-functional requirements of the software product. Construction. The construction phase is the third phase of the RUP. It involves writing the code for the software product, and testing that code to ensure that it works as intended. The output of this phase is a working software product. Transition. The transition phase is the final phase of the RUP. It involves deploying the software product to users, providing user support, and maintaining the software product over time. The output of this phase is a user manual that provides instructions for using the software product. In conclusion, software engineering is a complex and multifaceted process that involves the application of engineering principles to software development. It involves using tools and techniques to create high-quality software products that meet the needs and expectations of stakeholders. Software process models, process activities, coping with change, and the rational unified process are key concepts and practices that are important to understand in software engineering. By mastering these concepts and practices, you'll be well on your way to becoming a successful software engineer.